All right, so Peter and I are talking about collaborating on a programming project. Peter's background, he's going to tell us a little bit more about that, but he's been working on some, image processing code. Is that right, Peter?
Right, so signal processing code now, but image processing code in the past.
Great, and mainly working on as a solo programmer, we're going to look at how to work more in a team environment, what tools and practices he should use. So, Peter, tell me about what you're doing right now and what you hope to accomplish.
Sure, so currently I'm a medical student at Duke University, but I have a background in, I suppose, engineering and a little bit of experience with coding in image processing research at the NIH. So, with that background, recently I've been doing research where I'm developing code to process basically cardiac EKGs. And so, the medical field is kind of like the wild, wild west. There's all kinds of levels of experience in terms of coding. And I would say, I'm a fairly novice coder, but relative to other people, that I'm collaborating with, I'm probably one of the more expert or experienced people on the team.
Great.
So, I guess, at least for myself, I'm interested in developing good code where I can track changes to the code, and where other people, if they're interested, might be able to go in and modify the code. But I can slap people on the wrist if they're making changes that might affect the performance of the code.
Great, excellent. And then the code, how are you currently verifying that the code is performing correctly? How do you verify correctness of the system?
Yeah, it's a good question. So I'm running and developing all my code in MATLAB. So generally, I'll run the code in debug mode just to make sure that everything's doing what it's supposed to. And my code has various outputs that I save and look at. There's a lot of graphical and text output. I don't know of a better way, to be honest.
Great, yeah. So I just bring it up because we're going to touch on a lot of different topics kind of through this exploration, because I think you mentioned this idea of catching a breaking change and making sure that you don't allow your teammates to inadvertently break the working code. And so that led me to the question, well, how do you know your code is working? It sounds like right now it's mainly through visual inspection, right? You kind of have you run it over some known set of data and you try and see if the outputs look to be correct. Is that right?
That's right. Yes.
And then also, if someone were to submit a patch to you, you could review that patch and visually determine this is clearly doing something wrong, or if you visually can't tell, then you would have to run their code merged with yours, and then you would see if the outputs are correct. Is that right?
Yes.
Yeah. Okay. So I guess let's tackle this idea about collaboration first. This idea of we have a version history of our code, so you and others can audit how it came to be, or if there were any changes in a given file. And then also related to that, the ability to play gatekeeper, to allow people to collaborate with you, but to make sure that they don't break anything without your oversight. So we'll start with that, this idea of source code control, and then later on we can look more at tools for verifying your code's correctness in a more automated way. Does that make sense?
Okay.
Okay. So the first big thing I'm going to have you look at, you've probably heard of it, you may have even used it. Are you familiar with Git at all, or GitHub?
I've heard of it.
Yeah.
I don't remember if I've used it before.
Sure.
Probably not.
Sure. So basically, Git is it's the most popular right now, kind of the most cutting edge form of version control. It's an open source tool originally developed by Linus Torvalds, the same Linus who gave us Linux, actually. And he was using the tools available to him at the time for managing development of Linux, which is this huge code base, millions and millions of lines of code. And he found that when working on a distributed team, the tools of the time weren't good enough. Like, he had a lot of this kind of distributed development going on, where you had many teams, almost like a pyramidal structure. You had the networking guy who would send him networking patches, but meanwhile, that networking guy had maybe 10 or 100 guys reporting to him, and the same thing for every different subsystem of Linux. So anyway, that's a lot of background for you. The point is that everyone who's hip and on top of the best tools is using Git these days. It's freely available, it's open source, but the challenge is that using it can be a little bit challenging out of the box. So there was a couple guys in San Francisco who launched a startup called GitHub, and GitHub essentially gives you kind of this free, if you're doing open source, it gives you a free Git server to kind of help manage the collaboration around Git, where Git is doing the strict versioning of all the code, and it's like the engine powering everything. And GitHub you can think of as kind of like a nice UI or a central kind of collaboration space for using Git.
Okay.
So essentially the two go hand in hand. There are alternatives to GitHub out there if you decide you don't like it, but I'd say start with GitHub, and I can actually do a quick screen share for you, and I can show you what creating a repository looks like, and then we can have you step through the same process. Let me pull up a browser. Let me know if you're able to see that.
Yep, I can definitely see it.
And let me know if it's too small, if you need to make the font bigger or anything to be more readable.
Mm-hmm. It looks
Is it
good
all right?
to me. Mm-hmm.
So basically, GitHub.com, you'll want to create an account. So I'm going to just kind of bypass that step for right now. But the key thing is that you want to create a repo name. So in your case, you're working on, I don't know, something like EKG monitor or something like that. You can create whatever name you'd like. And basically what you'll do is you'll, by default, if you look at this collaborator screen, pardon me, if you go to the collaborator screen, right now there's no one added as a collaborator. So that means that me, the owner of this project, this repository, I'm the only one who could push code to it by default. But since it's open source, anyone can make a copy to it, and you can and can theoretically submit a change request. I call it a pull request to it. So we can even do this drill right now. So I'll, just for the sake of this example, let me share that whole screen, and I'll just show you what that basic workflow looks like, and then you can ask me what questions you have about it. Oh, it looks like, what do you call it? It looks like Hangouts is not playing nicely with my window manager. So I'm going to have to do this one step at a time. But basically, what we would do is here in the terminal, I would basically, I'm getting a copy of that project that we just made. So see this git clone command? This right here, this is going out to GitHub and saying, hey, give me a local version, a local copy of all the code that's up on this EKG monitor on GitHub. Mm-hmm. And then what I can do on my local machine, I can open up, let's say, the README file and say, EKG monitor, and I can say this project, oops, 1 second. This project contains MATLAB code for processing EKG signals or something like that. So I have my crappy little README file. I can add that. Oops, sorry. Oh, I'm in the wrong place. I'm in, if you look on the right, I'm in current. I really should be in EKG monitor.
Okay.
So I'm going to move my README file in here, and then you can see there's our README file. If I cat it, we'll see the contents. There's the contents of the file. If I ask Git what the status is, oh, by the way, there is a GUI version of all these tools. Mm-hmm. I prefer the command line because they're more universal, and I think they inform you more about what's going on. Okay. But the basic idea is that I could work on this locally entirely. I can say I can add a commit, and it asks me for a message. He says, you've created this new file. What comment do you want to give it? And I say, added README file with the project name and a brief description. Mm-hmm. And then over time, we can just continue to add new files. So I'm not familiar with MATLAB very much, but I can write a little Python hello world program. And then likewise, when I come back to Git, you'll notice we have this untracked file called hello.py. If I add that, it's now marked to be added to the next change. If I do git commit, now I've got this new change. You added this file, hello.py. I can say added a Python hello world program. And so the point is that over time, you can make these little snapshots of your code. We call them commits. But if we go back over to the GitHub website, then we're going to notice that it's still blank. It's saying, hey, you haven't uploaded any code yet. Here's what you need to do to push your code up to GitHub and put something in this blank space. So if we go back to the shell here, then what we'll be able to do is if I say git push origin master, well, basically, let me show you, git remote show origin. Origin is the place that I cloned my code from. You can see here that this represents the URL that I pulled the code from in the beginning.
Gotcha.
So now if I say, hey, and when I say git status, it says you're on the master branch. The idea being that if you ever work on experimental code that you don't know if it's going to be shared with others, you can work on a parallel stream of development. We call it a branch of development. So for example, if someone has a new algorithm for your processing, you could say git checkout experimental algorithm, and you have to say B for new branch. And then I could say, I don't know, go to hello.py and say for I in range 1 to 100, print I don't know. And I can say, this is the change that I made. I can say commit all changes with the message added a 1 to 100 for loop. And then we can see here, I'll highlight this in the GUI. This might be a little bit eye-opening for you. We can see here in the GUI that on the master branch over here, I only go up to Python hello world, but I can use this experimental algorithm branch separate from the master branch. And these two can work in parallel as long as you need them to. In our case, we're just going to upload the master branch to the GitHub website because that's the one we want to share with our team.
Gotcha.
So let me stop the screen share. Seems like, I'm mousing around on the wrong monitor. I'm mousing over on the shared screen, not the active screen. Anyway, so now if we say git checkout master, now we're on the master branch again. And I can say git push origin master, and it says upload it to GitHub. Your master branch locally to the master branch on GitHub. And so now if I change screens back to the browser, then you can see right now it still says we don't have any code, but if we refresh, then ta-da, now it has a README and it has a hello py. And if we go and click on commits, you can actually see it has all the versions available to us right here.
Great.
So I'm going to pause for a second and ask you if anything so far, because I know I moved really quickly, I want you to tell me, did anything so far need further clarification? Should we go over any of that you've seen so far again? Or should we start experimenting with it and showing you how you might collaborate with me on this project?
Yeah, I have two questions, I think. One is, so we've committed the master program, or I guess set of programs, back to the server.
That's
and
right.
We have this experimental branch that we have locally that we're working on.
Yeah.
So let's say I make changes to the local branch.
Yeah.
And then somebody makes changes to the main program uploaded to the server. And I want to try to reconcile these changes. Is that doable? That's
very doable. This is the whole system is designed around that use case. Basically, the reason Git is so cool is it does keep a very granular tracking of what's been changed. Like if you come back to this change tracker screen, this little visualizer, something that I didn't highlight before is that on the bottom here, each of these versions up top, it actually tracks a line-by-line diff, we call it. a line by line, like a delta between
Yeah.
the old version and the new version.
Gotcha.
And you can see this at the top. It's saying like, what is this? Added 1 to 4 lines. Is that what it says? It's something like that. Oh no, remove line 1, added lines 1 through 4. I think that's what it says. Where this is like 1, 2, 3, 4, or 1, 2, 3, 4. So anyway, so the point is that on a more sophisticated project, this becomes more and more complex. But Git essentially has all this line by line tracking built in. So in the case that you and I are modifying different files, then Git will auto merge no problem. In the case that we're modifying different lines, Git will auto merge no problem. In the case that you and I are modifying the same line, then Git will notice, oh, this might be a conflict, and it'll ask for human intervention.
Gotcha.
So that's how that goes by default. But something I want to show you is that there actually are some nice like teamwork, collision prevention tools built in by default. So something that I want you to do, I want you to log in to this page right here. I want you to go to, make a GitHub account, go to this GitHub page, and you should have the ability to change my code and then request that I accept your changes into the main line.
Okay, sure. The only other question I had was, so I personally am working a lot of times with, I guess it's called personal health information.
Yeah, PHI.
And so I was just wondering if, using GitHub and these servers, that information is secure.
Okay, so that's the problem. So PHIs basically you need to keep under complete lock and key, and using a publicly, I'll put it this way, using a public GitHub repo, definitely not okay for PHIs. Using even a private repo on GitHub, also not okay for PHIs. Because as far as I know, GitHub is not HIPAA compliant and will not sign a BAA with you, a business associates agreement. So no. So if you have PHIs, then what you're gonna have to do is you're gonna have to basically, you would have to self-host Git. You would have to basically make sure that there's somewhere, on your corporate network that is, fully, locked down, secure, blah 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 blah, and put it on there.
I see, and I would not be able to use GitHub.
And if you're putting your PHIs in the version control, then you would not be able to know. My suggestion is that you keep the PHI stuff separate from the core source code, if possible.
Right.
Could you tell me about your PHI use case? Is it that all your like EKG data, is that considered PHI, or is it the names attached to the EKG data?
It's the file names associated with. Well, so right now it's just the file names. So potentially we could, no matter how I change the file name, there will always be an identifier. I have to have some identifier to know which file it is, right? So so there's always going to be some PHI, at least a medical record number attached to the file.
Well, okay. Well, what if you aggregated them? Would that be useful, or would that screw up your research? Like if you have 500 patients, if you create 250 different IDs.
Well, so that's the thing, is the IDs themselves, I believe, are still considered PHI.
Well, no, but it's only if it's uniquely identifying. So I'm saying that if you lump patient A and B together, and patient C and D together, and patient E and F together, does that work, or does that throw off your research?
I think I'd have to be able to track. I'd have to be able to trace back. Yeah.
Yeah. So if that's the case, so if that's the case, my understanding is that anytime you create a uniquely identifying ID down to a person, you fall under HIPAA. Yeah.
Right. Okay. Well, let's use GitHub for now. And so GitHub is an SUI, you said? I'm not familiar with that term actually.
Oh, I don't know what I said. GitHub. Okay. Is this in terms of what programmers call it? Is that what you're asking for, or what word are you looking for right now, Peter?
Just yeah, what is it called? I heard the term SUI. I wasn't sure what that was actually.
Maybe. Oh, wait a minute. Is it? Oh, it's 6:30.
I have got to take another call.
Okay.
So we're gonna have to adjourn this for right now. Okay.
Okay, that's all right.
I'm gonna see you in a little bit. I just realized I gotta go sell a table.
No problem. Yeah. So I created a GitHub account and
yeah, create the account. Let's hit the pause and then we'll resume this in a little bit. Okay.
Sure.
All right. See you in a bit. Bye.
Bye.